Using the second derivative test does not mean find inflection points. It means I'm going to use a second derivative to do something that the first derivative could already tell me. You might say, well, why do we have two ways to do it? Sometimes you have no choice but to use this method. You will, whoopsie, my smartboard's being weird today. Anyway, I'll go put that on there. So I'm using a second derivative to do a first derivatives task. Had this said, use the first derivative test, I would have done this. I'm still going to because they start the same way. First derivative test for relative extrema says, I need to make a sine line. This is the first derivative test right here, okay? But let's pretend it said first derivative test. In order to do that, I need to take a derivative. Right? And I find the what? Critical values, where it's 0 or where it does not exist. I still do that for the second derivative test. My mind flow is not any different yet. I still figure out, well, where is that equal to 0? To do that, I always factor. So I'm going to factor that negative out. And that's going to give me an x to the second, right? And then a minus 1. I want to know where that's 0. I have 3 critical values. What are they? 0, 1, and negative 1. The first derivative test says to do this. That's where there's zeros, and it says to do sign tests. I'm going to do that so you can see the difference. Okay? So I'm running right now. Which test am I running? First derivative test. I'm going to draw the conclusions and then I'm going to cross off the things that I don't need for the second derivative test. So I go and I test a number way over here, let's say 10. This would be negative and this would be positive, so it would be negative. Do I assume it alternates? No, only for sines and cosines. Then I'd pick something in here, maybe a half, right? And this would still be negative. This would also be negative. So what would I have? Positive. Then I pick negative a half. This would still be negative because of that 15 being negative. And now this guy is going to be negative as well, so that's a plus. And I'm going to tell you over here this would be a minus, just so you can see it, because this will be a negative times a positive. So here's what I know from the first derivative test. I know that there was a relative minimum at negative 1. I know that there is a relative maximum at 1, and I know at 0 what happened. It went down, up, then what did it do? Plateaued, right? I know that. From the first derivative test, my conclusion is rel min, plateau, rel max. But I'm not doing the first derivative test. So I'm going to cross that out. I'm going to use the second derivative test to make the same conclusions. What does that say I do? I still take those critical values or critical points. They are still 0 and 1 and negative 1, but I don't put them on the sign line. Who knows what I do next? This is where it's different. I take a second derivative because it's called the second derivative test. I am not looking for inflection points. I'm looking for relative maxes and mins. So I take a second derivative test. So I go up here and I say that's negative 60 x squared plus 30 x. Oh, thank you. X cubed plus 30 x. It's still good to factor it because you're going to be running some plugging numbers in, but I'm going to leave it like this. I am not looking for the zeros. What would the zeros give me? Inflection values, possible inflection values. I'm not looking for that. What I want to do is take these critical values and I'm going to plug them into the derivative. I'll plug 1 in first. Because what I know is these guys right here are possible turning points, possible maxes and mins. So if I can figure out how it's turning there, I know which one it was. Here, watch. When I put in a negative 1, I'll get a positive 1, I'll get negative 60 plus 30, which is negative 30. That's the value of the second derivative. What does that tell me about the function at 1? It's concave down. So if a function's concave down at a turning point, it must have been a what? Max. So you'll say this is less than 0, which implies concave down, or you could say implies a max and I'm just going to tell you to find the x value. So there'd be a maximum at x equals 1. Does that give me the same conclusion that the first derivative gave me at 1? I crossed it out, but do you see how it was a max? It's the same conclusion, different way to find it. All right, next step. I would do f double prime of 0. Why? Because it's a possible turning point. When I plug 0 in, I get a 0. Do you remember what that means about the second derivative test? It's inconclusive, or sometimes we say it fails. So that just means with the first derivative test, I don't know. Inconclusive. I have no idea. It means you'd have to revert to the first derivative test to figure it out. And I wouldn't make you do that. You just have to know it's inconclusive. Did you hear what I just said? I know from the first derivative test it was actually a plateau, so it wasn't a max or min. But based on this test, I couldn't draw a conclusion. Then I plug a negative 1 in, and I go plug it in here, and I'd get a 60, right? Because that'd be a negative times a positive, and then I get a minus 30, because I'm putting a negative 1 in here. I get a 30, which is greater than 0. If a second derivative is greater than 0, what's the function doing? It's concave up at that turning point. How do I know it's a turning point? Or a possible turning point? How do I know that? Because, it was a critical value. They're all possible turning points. But this one then, that would imply that I have a relative min at x equals negative 1. So which test is better? And which one are we going to use the most? The first derivative test. But there are times, especially College Board, they won't give you the actual function sometimes, and they'll say, is the critical point 1, 0, is that a max or a min? And the only thing they hand you is the second derivative. So they make sure that that you have to plug that into the second derivative and see if it comes out positive or negative for concavity's sake. Like they won't even give you the original. Does that make sense? That's why I have to teach you the second derivative test, even though when we use it, it's one we're going to really have to bring back in May because we're not going to use it hardly at all. We're going to use it tomorrow on one problem on the test, and then most of the time we'll be using first derivative test. We are done. All right? I'm going to hit done on here if I can